what we've spent so far in our lessons is working with, give you an equation in standard form, or manipulate it so it's in standard form, and then go out and graph it. Now we're going to do the opposite. We're going to give you some information about the ellipse, and we want you to come up with what would be that equation in standard form. So here's what we give you. We give you the two foci points, -1, 0, and 1, 0. We also give you two vertices, -2, 0, and 2, 0. So let's go out and graph what we have. And then we'll come up with what the equation will be, to pick apart some of the stuff. All right, so in red, we have a point here at 1, 0, and -1, 0. Those are your foci. And we have your vertices. 2, 0, -2, 0. Vertice, vertice. So think back to what we've learned already. Foci points run along the major axes. So that means my ellipse has to run along here. So that tells us then that our ellipse is a horizontal ellipse. So the general form equation for a horizontal major axis ellipse is x minus h all squared. The a has to be bigger in the first fraction. Then y minus k all squared over b squared equals 1. Now what we need to find is the center, the a, and the b, and substitute in this green equation. Alright, so we've identified it's the horizontal ellipse. Let's find the center. So imagine, I don't know exactly what this ellipse looks like. I'm just going to pretend it does something like this. I don't really know for sure. I don't know how high it goes. I don't care at this point. Okay, but I know it does something like that. We need to find the center. The center is the midpoint of the vertices or the midpoint of the foci. It's the same thing. This is a nice easy one. Halfway, that would be your center. Nice origin, right? So the center, which in the equation is your h comma k, is at the origin. So when we plug it back in for the h and the k, we can plug in 0. Now we need to find the a and the b. The a value in the equation is always the center along the major axes out to the vertice. So this distance right here is a length of 2. So that is going to be your a in your equation. So I'm just going to write that down over here. A equals 2. Remember, the major axis length is 2a. So 2 times 2 would give us 4. So the length along here is 4. I don't really want that on there in that picture, but let's erase that. So it should be a distance of 4. So now we know the a value. We have to find the b value. The b value is the height up and down. We don't know it yet. We can't find it because we don't know those points. But we have something else that helps us. The foci points. The foci starts at the center. The distance here to here is a length of 1, which is also your c. So now we know the c. The c is from the center to one of the foci points. And we said the b is unknown. We have to find the b. So you've already spent some time with this equation. This should look familiar to you. C squared equals a squared minus b squared. We know 2 out of those 3 things in the equation. We know the c is 1. We know that a is 2. and we want to find the b. So we can write the equation of this ellipse. So now we just solve it for b. So I'm going to solve by undoing. I'm going to add b squared to both sides. I'm going to subtract 1 squared from both sides. And I'm going to solve it for b. So 2 squared is 4. 1 squared is 1. 4 minus 1 is 3. Undo the b squared, and you get the length of b, which is square root of 3. So if I wanted to go back and graph this ellipse, I could. I know that this b value up here in the green is the square root of 3. But I don't care. I'm looking for what's going to go in to this green equation right here. I know the h, I know the k, I know the a, I know the b. I can now write the equation. And that's what I'm going to do next. All right. My h and k were both 0. So I don't have to worry about that. My a was 2. So in the denominator, that has to be a squared or 2 squared. The second fraction, the b, we found to be square root of 3, or the b squared to be 3. So now I'm just going to clean up that 2 squared. There is your standard form equation for this ellipse, given the foci points and the vertices.